Okay, we're taking a look at problem 41 on page 371. We have the cube root of 48x to the third y squared divided by the cube root of 6x to the fourth y. So I've written it here on my whiteboard. And the first thing I'm going to do, I'm going to put everything under the same radical. And so if you remember this from properties of radical expressions, we know that we can do this. And so I'm going to go ahead and divide everything out. And when I do that, I get 48. 6 goes into 48 8 times. I have x cubed and x to the fourth. So when I subtract, I get x, and the x goes at the bottom. And then I have y squared minus, this is an invisible 1 here. So 2 minus 1 is 1, so I'm left with y at the top. And so when I rewrite it, I get the cube root of 8y over the cube root of x. Well, I know the cube root of 8 is 2, so I have the cube root of y over the cube root of x. Now, if you remember, we don't want to leave radicals in the denominator, so I'm going to have to find a way to multiply, or find something to multiply to get rid of that cube root. So since I'm dealing with cubes, I'm going to multiply the top and bottom by the cube root of x squared. And I chose x squared so that when I multiply x squared times x, I get x to the third, and that gives me just plain old x. So when I do that, I get 2, the cube root of y times the cube root of x squared all over x. And so now I can combine this, and I get 2 cube root of y x squared, because they're all in the same cube root, over x. I hope this helps.